All right, welcome back. Part five. Yes, part five. Part five of diesel after treatment overview. Hopefully, you guys gone and seen and taking your time and watching all these videos on after treatment. This is the second to the last one. I think we're going to do one more after this because in this segment, I am going to be discussing sensors. Obviously, there's more in-depth information involved that's more targeted towards technicians, but this ought to help you understand the role of the sensors. Yes, on the after treatment, we do have quite an array of sensors. So in this case, let me get this going here. Um, Hopefully you guys have learned a little bit while I'm trying to load this puppy. And in this case, what I mean by that is it's helped you understand what's going on in an after treatment system. So let's move on. We already talked about the indicators. Obviously, on the dash, we have a NOx reducing SER light, and we also got the check engine light, which is giving us codes. Probably the biggest frustration for a lot of people that have owned these diesels and have made a mistake pouring DEF fluid into the diesel. It is such a busy thing for shops that I work with. And what I mean by that is that there's what we call contamination kits and various vendors that supply injectors and pumps and pretty much all the fuel system of a certain engine, such as a Duramax or a Ram Cummins or a Power Stroke. And in this case, the contamination kit means that there has been destruction in the whole rail system, common rail injection system, fuel, in other words. And in this case, it requires everything to be replaced because it's contaminated. Now, with the CP4 pump and other issues going on, or just contamination, that has taken out the common rail system. So in future training, I'll get more into the common rail again, talking about how contamination is a problem. But another issue that we find in fuel is actually DEF fluid. So somebody makes the mistake of pouring maybe a gallon, whatever, maybe a quart or a pint, whatever it is, they're pouring DEF fluid into the fuel by mistake. But to me, it's just a matter of understanding what's going on in the diesel. And in this case, we see the fuel cap and we see the DEF fill. And yes, people tend to pour it. And even I've had customers in the past come up to me saying, "Hey, Tony, what about this new fuel additive? That's DEF fluid." No, DEF fluid, it is not a fuel additive. You pour it into the DEF tank. That is separate. It is a third solution of 32.5% urea mixed with water. So in this case, it's bad for the fuel system. So you do not pour DEF fluid into the diesel. That's a big no-no. So two separate tanks, but unfortunately, manufacturers thought it was pretty smart, which is not, to put the DEF fill next to the fuel fill. Now, LML Duramaxes, they did put those in the engine compartment. In other words, to fill the DEF fluid, you had to open the hood on those Chevy and GMC trucks. But later models, they put them together like you see in front of you here on the screen. So big headache there. Anyways, moving on. We already have looked at the after treatment. We see a diesel oxidation catalyst, diesel particulate filter, like in this case. What you have to understand now is what sensors are involved and in understanding or having the computer do its job. So now remember, this is an emission control system. After treatment is an emission control system. So that means it has to actively monitor itself. So there's what we call monitors. Yes, there is a term called monitors, and the job of the monitors is to monitor the whole system to see if it works. And if there is a problem, it must diagnose or try to isolate the issue where it is. One specific sensor can set an array of 6 to 8 different codes, if not more. So therefore, the computer heavily scrutinizes. So it is fair to say that as that truck's going down the road, that truck is actually running various self-tests and it's testing, testing, testing. So yes, I can say that as that truck's going down the road, there's a portion of it that's testing, 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 testing. That's his job. And if it passes whatever component that it's testing, guess what? It has to continuously test. Okay, so that's the job of OBD2 law, which is onboard diagnostics generation 2. That is part of the Clean Air Act. So therefore, these vehicles by law must not only set a diagnostic trouble code and also turn on the check engine light, but it also must diagnose itself over and over and over again, meaning test continuously. And at that point, if there is a failure, yeah, boop, light comes on the dash. So therefore, that's the job of it. Okay. So in this case, what do we see here above the DLC and the DPF? We see an array of sensors. We see these pressure test ports right here, these tubes. This is the inlet, this is the outlet. So obviously this must be the differential, the diesel particulate filter, DPF. So it's monitoring itself, and you'll notice this goes to a differential pressure sensor. So that's one of them. We'll look at them here in a second. And then we got to have temperature sensors too as well, which we can't see very well, but yeah, we have temperature sensors as well. So any system, as we look at this 2013 Ram Cummins system, you're going to see that there's an array of different sensors themselves. There's the bungle or the ports where an array of these different sensors are. So they could be the exhaust gas temperature sensors, meaning it measures the various different points of the temperature of that exhaust. So a after treatment system like this one can have between 3 to 4 sensors, if not more, depending on the model. So therefore, it must monitor itself. And then right here, we can see our DEF fluid tank where we pour the DEF fluid. That's the tank right there. This is the fuel tank. But in this case, the DEF fluid also must be actively monitored. What I mean by that is there's a pump in there, so that pump must be tested. And then you got the heater in the tank to prevent, again, or to allow the de-icing of the DEF fluid because it could ice up, right? And then freeze up, better yet. And in this case, you also got other components such as your DCU, your diesel control dosing control unit, that controls the doser or the reductant injector, same thing. And again, you got a various different sensors. So again, the practical easy ones are exhaust gas temperature sensor, the pressure differential sensor that goes across the DPF, and again, you got other sensors too as well. This model will also use an ammonia sensor, which we won't go into because this is the Ramcom's the only one it uses, but it senses ammonia. So the computer needs to make a logical conclusion on what's going on with many different things. But the main mission is two things, like we started off in part one. It's looking for a drop in particulates, which is soot, and it's also looking for a drop in NOx. So the easiest one to understand is before the whole after treatment and after the after treatment, you're going to find there is a NOx sensor. So in this case, there's your SCR catalyst, and after SCR catalyst, there must be some NOx sensor. Again, pre and post NOx sensors. So we have to see the NOx levels before the after treatment and NOx levels after the after treatment. Okay, so he's going to go ahead and see if there is a drop in NOx. That's the whole purpose there. So how are we dropping NOx? Remember, we inject a solution of urea DEF fluid, which is urea with water, that readily is swirled and converts to ammonia, and it is the ammonia that breaks up the oxides of nitrogen, aka known as NOx. So once again, the pre-NOx sensor is going to evaluate where the NOx sensor levels are at, and then the one after the SCR catalyst or NOx brick is going to go ahead and measure the NOx levels if they drop. So if there's no drop or significant drop, up to 70%, if not more, of NOx level drops, and therefore that's going to go ahead and turn on your check engine light and threaten to go to derate an array of things. So, but in this case, it's all based on NOx sensor input. Now, there is another sensor that I don't show here, but actually I show it over here, is actually, believe it or not, the fuel level sensor. Fuel, like in diesel fuel level sensor is also used because the computer will say, hey, again, the computer will say, hey, that the engine has consumed so many gallons or liters of fuel. So in this case, if he consumes so much fuel and it runs under different loads and speeds, he's going to use an algorithm, a calculation, if you will, and he's going to try to determine the average soot mass, how much soot has been accumulated, and that's going to make the deciding factor whether he runs an active regeneration or not, or displays messages on the dash. So therefore, yeah, the fuel level sensor does work with your pressure differential, and in this case, we're looking at pressure difference there, what's going on there. So what else do we got? Well, again, we got our pressure differential. We got to have some kind of NOx sensors. We've knocked that. And then we talked about the exhaust gas temperature sensors. But let's take a look at the whole picture here. Here we can see an LML Duramax. Once again, number ones. Let's see, our number ones are our NOx sensor, pre and post NOx sensor. Number two is exhaust gas temperature sensors. So you can see 1, 2, 3, and I believe there was a fourth one. No, we have just 3. And then that's exhaust gas temperature. So it measures the temperature before the diesel oxidation catalyst, the one before after. So therefore, I mean, where do you want me to go here? Hold on. Let me start over again. Exhaust gas temperature before the diesel oxidation catalyst. Number 2, we have here after diesel oxidation catalyst and before the SCR brick. So therefore, we're measuring the temperature before the SCR, and that's about, oh no, we're measuring also after the SCR there too. So there you go. It doesn't matter. All you need to understand is that the computer's keeping an eye at different parts of what the temperature of that exhaust is. So Then number three, we see our key components. Number three is your diesel oxidation catalyst. Number four is your, let's see, we're injecting DEF fluid, so that must be our SCR catalyst. And then this guy, number five, is our diesel particulate filter, because I see the pressure differential measuring across it, so that's got to be our diesel particulate filter. So that's five, right? And we got number six. That is your exhaust cooler. Yes, we got to have, you'll notice that these Duramaxes and Fords, and just those two, have what we call a trumpet style exhaust. You know, it kind of trumpets out, you'll notice. And what it does, it's a cooler, because since these gases get so hot, it actually cools down those gases, average of 90 to 100 degrees of temperature drop. So now, when we talk about temperatures, please understand when this unit is running a regeneration, we saw in previous videos that the temperature can exceed over 1,000 degrees, right? 1,000 degrees Fahrenheit. So that would mean that, you know, could you imagine, like here in Las Vegas, for example, we have these parking garages for the hotels, the casinos. And in this case, you know, though, what if happens if a car breaks down? A lowboy tow truck goes in there. So imagine how hot it would be around a small, low ceiling parking garage. You know, let's say you're on level 5, fifth floor. And in this case, that truck has to go fetch a vehicle out of there. So in this case, could you imagine it goes in a regen? The heat that it actually generates can be dangerous, especially if somebody walks around it. Or maybe a school bus or a commuter bus, you know. Let's say the people are walking out or children are walking out the bus and it goes in a region and they could walk literally in front of that exhaust tip, and what could happen is that they could get second, if not third-degree burns. So therefore, there's got to be a cooler to protect about that. So there's got to be some protection there when it comes to the heat. So therefore, number six is the cooler. Seven, like I said already, is our pressure differential. And then number eight, we have various components inside the DEF fluid tank. So this is our DEF fluid tank. We need to have some kind of pressure sensor. The sensor is going to measure what is the depth pressure, and most DEF systems work above 70 psi of pressure. So yeah, we see the injector injecting the DEF fluid, or better known as the doser. But in this case, it has to have some kind of pressure sensor. And obviously, it's got to have a pump. So therefore, number 12 is going to be the pump. And something's got to revert the flow, because when we actually add DEF fluid, you turn the key on, depending which model. Some will turn on later, some will turn on at the beginning when you turn a key on. And once others will turn on when the engine's running. So therefore, what's going to happen is that the computer will charge the system with DEF fluid. So every time you turn the key on or fire up the engine, what should happen is the system is empty. At that point, the pump will be turned on, the injector will be commanded on, and DEF fluid will be sent through the line to the DEF fluid injector. Now, at that point, after a few seconds of running, it's going to purge the air out and close. And at that point, the DEF fluid injector will be ready to inject DEF fluid. But when you turn the truck off, the reverse happens. So therefore, that's what number 11 must be, is the reverting valve. So the reverting valve, what it does is that it reverts the flow. So therefore, it empties itself when the truck is shut down. So therefore, at that point, it's going to go ahead and open the injector up again and revert the flow. So the pump is going to suck all the fluid out of the injector and the line and pour it back into the tank. And therefore, at that point, the injector will be commanded open and pump is turned off. Okay. So those are the average components that we see right there. And you got to have some type of temperature and heater. So there's got to be a temperature sensor, and there must be a heater as well, because again, since it's mostly water, DEF fluid AdBlue is mostly water. Again, it's 32.5% solution of urea with water. Can that freeze in very cold temperatures? Yes. Not to mention, what's not illustrated here is this line from the tank to the injector, the reductant injector that is, or DEF fluid injector. This is electrically heated as well, so it prevents freezing. So there you go. So yeah, it's designed to work with cold environments, but it takes a while for it to thaw out. So therefore, there must be a tank heater, and there also must be a line heater for that there. So hopefully that explains it right there. So you got all these sensors right there. So here's an example. Here you can see an exhaust gas temperature sensor, and you really gotta, for those of you that work in the trade, you probably understand this, but this sensor goes from very cold, probably under 20 degrees Fahrenheit, and it could actually go all the way to the 1,000, 1,400, 1,600 degrees. So it has a wide range, okay? So therefore, it is a what we call magnetic resistive sensor. It does, no, not magnetic resistive, excuse me, temperature resistive sensor, so therefore it does change resistance with temperature. But yeah, that's an exhaust gas temperature, and they're very thin and they're not that hard to break, so you got to be careful with them, especially at the base. And then you got your NOx sensors. Now, the NOx sensors usually, for most models, comes with a NOx sensor module. So there's the NOx sensor and the NOx sensor module. And these actually communicate in the network. So therefore, there's a network. Yes, we call it CAN, which stands for Controller Area Network. It's a two-wire communication, so you got modules talking to modules on what we call CAN communication. So, and that's changing too to LIN and so on, but that's another class in itself. So therefore, what I'm trying to say is that, yeah, it comes with a NOx sensor. Only one model I know of that you can actually get the NOx sensor off, but most of them actually are plugged in and it comes with the NOx sensor module. So there's two examples of it too. So again, what else are we missing? Well, we also got your differential pressure sensor. So there's our, again, a differential pressure, and you're going to see the two tubes, or you can see two hoses. So in this case, all it's doing is measure the pressure, excuse me, the pressure differential between the inlet and the outlet of the diesel particulate filter. So he's measuring that pressure difference to see if it's starting to get soot loaded. Okay. So therefore it becomes more soot loaded, the diesel particulate filter. What's going to happen is that he's going to read that pressure variance. It's going to go high, 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 high. And eventually it's going to tell the computer that perhaps we need to run an active regeneration if it cannot do it passively, like we discussed before. And then on the other side, we see a sample. This is a Ford Power Stroke. This is a DEF tank along with the DEF pump assembly. So therefore, it's all top fed. Ram Cummins are from the bottom. Those are three-phase pumps. Well, these are different. These are conventional two-wire pumps here on this. So therefore, there's a lot going on in here. Like I told you, heaters, pressure sensors, temperature sensors, and you also got the reverting valve too as well. That's all part of this assembly. So they're not cheap. Okay, they're very expensive. So one of the things that we look for when we look at a DEF tank and the lines and so on is if we see any crystallization, because that would tell us there's the DEF fluid leak. So we have had many trucks come in where they actually have DEF fluid all crystallized all over. So it's all crystallized and we got to chip it away to see where the leak is at. And many that do repairs don't put the seal right on this tank. So therefore, you got to make sure you put that cap in right with the whole unit. So be aware of that. All righty, so therefore there's a components. But what I don't have shown is that Ram Dodge, this is a Ram Dodge diagram right here. And what you're going to see here, there's our diesel oxidation catalyst, diesel particulate filter, and there's our SCR. So this one's different than what we saw before. We've shown this before. And then we got an ammonia slip catalyst. So the sensors used are relatively the same except for a few extra ones. Here you can see an exhaust gas temperature sensor, another exhaust gas temperature, then another one, and another one. So this one has 5 sensors right there of exhaust gas temperature. So therefore, we'll be able to read that on the scan to all the different temperature readings. But you're going to see we have our pressure differential across the DPF. So therefore, this represents pressure across that we're monitoring. And then over here, what you're going to see on the SCR, you're going to see an ammonia sensor. That's what NH3 stands for. So therefore, there's going to be an ammonia sensor. That's a new sensor that's been on the Ram Cummins. So it's going to measure the ammonia content. You're like, oh, those of you that didn't watch part 1, 2, 3, or 4, what happens is that when DEF fluid goes into the exhaust, like as you can see here injected, it readily converts to ammonia, and it is the ammonia that breaks up the NOx. So here we could see our pre-NOx sensor and our post-NOx sensor. So again, we're measuring to see if we see a drop in NOx sensors, and those guys are the key players there for NOx levels. So there you go. So it's showing you in the DEF fluid tank, the pump, the heaters, the level sensor, the real quality sensor, and all the other components that are all part of the DEF fluid AdBlue tank there. So that's what we're looking at. So yeah, we got an array of different sensors going on there. So your job, again, is to understand that there is sensors. So therefore, to understand if we're reaching those light-off temperatures for the catalyst, it's looking at exhaust gas temperature. If it wants to see if there's adequate NOx level dropping, it compares the pre and the post NOx sensor. If it wants to see if there's too much DEF fluid being injected, it's going to look at the ammonia sensor. So therefore, we got an ammonia sensor there. And then it's doing self-diagnostics on the pumps, the heaters, the level sensors, everything. So there's a lot of diagnosing as this truck's doing its job because it has to actively monitor this. So yeah, the engineers did a lot of work to make sure this is all doing its testing and making the government happy to make sure that it meets those NOx levels and also those soot levels. So makes sense? So therefore, onboard diagnostics allows the computer to self-test itself to see if it is malfunction. And if it fails, let's say there's an open wire in the exhaust gas temperature sensor 2. And if it sees that, it's going to say, hey, I got an open circuit. It's going to set a diagnostic trouble code for it and set a code for it, right? So in this case, what happens when the problem's intermittent? Let's say the connector is loose. Therefore, it's going to intermittently pass and fail because it's got a bad connection. So therefore, that's the ones that are challenges for us techs to figure out what's going on. So, but for now, I just want for you guys basic overlook is please note the sensors are doing a job, and that job is to monitor and also allow it to function correctly to do its job for different road conditions. Because obviously, if we have a cold start, we got to wait till it warms up. We got to get those catalysts hot because you're not going to inject DEF fluid if it's too cold, you know. So therefore, we got to get hot, or maybe it's frozen. So therefore, it's got to turn on the heaters on the line and also turn on the heaters in the DEF fluid tank. So therefore, that time has to go by, but there's got to be a temperature sensor that reads that temperature in the tank. So therefore, a lot going on. So again, the sensors are playing a key role. So us as technicians, we have to use these sensors to our benefit. For example, we saw the pressure differential across the diesel particulate filter of the DPF. We're looking for an average of 3 psi or more to know if it's loaded or if I can actually run a regeneration with my scan tool. So now remember, sidebar, on a Ram Cummins, you cannot run a regeneration at will. Okay, you can't run a regeneration at will because it has to have a code 1451 set. If it doesn't have that 1451 set, you can't run an active regeneration with your scan tool. So, and those of you that have tuners and you want to run regeneration now. Now, finally, okay, so we talked about sensors. One more word based on comments that I've been reading that you guys have given me and other people reaching out to me is remember something. I know that a lot of you, after watching these videos, if you really took this to heart, don't panic. And what I mean by that is, oh man, I got to watch all my sensors, see what's going on. No, 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 no. The system using these sensors is self-monitoring itself. And in this case, as you're driving down the road, if it comes a time that it needs to run a regeneration, it's going to do it. So you'll never see it. In many cases, these trucks you can be driving and you won't know it's running a regeneration. Okay. However, when he needs your help because maybe the truck does too much stop and go, too much idle time, you know, it's going to give you a drive to clean message or something about clean exhaust message on the dash. And if it still can't do it, eventually it's going to turn on the check engine light. Okay. So therefore, you know, that's where we might look at maybe it needs a regeneration, or maybe I need to diagnose, maybe there's a malfunction of any kind, right? So there you go. So therefore, let the system do its job. Your job as an owner of a vehicle is to properly maintain that truck. And what I mean by that is change the oil like we talked about, make sure your air filters are clean, make sure you actually maintain your fuel filters and, you know, drive the heck out of it for all I care. But in this case, all I'm saying is do your proper in other words, your due diligence of doing your maintenance and you're going to be fine. Should there be a malfunction, you'll be informed about it. But you can stare at all the data. If you want to buy an aftermarket tuner or scan tool, you're really kind of stressing yourself out. Let the diagnosis, you know, come to us as technicians for those that know how to do it. But you know, search out help if there's a malfunction. But understand that, you know, the system's supposed to work by itself. Yes, I know there could be problems because there's probably a few truck owners that probably had that check engine light with less than 1,000 miles after you bought it. I understand that. But all I'm saying is, if a properly system is working correctly, again, your job is to maintain that truck. Oil does a big deal, fuel filters does a big deal, air filter does a big deal, you know. So therefore, babying the truck does not help. Okay. If you could see from manufacturers how they test these engines on the stand, you'd be in awe. I mean, these trucks run full load for who knows 30, 60, 80, 150 hours, if not more. They run them continuously when they do endurance tests. So in this case, understand it can hang, provided again that you maintain it. So, all right. Hopefully this helped. Quick tip. Any questions, send any messages. Thank you for those of you that have supported. We got over 3,100 subscribers. That's nice. That's good. Let's keep growing it. But again, any other requests or questions, let me know. With that, thank you. And until next time.